All right, so now we're going to put it all together and do some examples of graphing from the beginning of the note. So if you need to, you might want to go back and review the different types of things we're going to do in the graphing section. And then I'm going to do all of them at this example. So the first thing it's asked you to do is find the discriminant. And the reason you want to find the discriminant is because it's going to tell you what kind of X-intercepts you'll have, which is very useful before you move forward. So part A, we just want to find b squared minus 4ac. And once we do that, that's going to be done by a is equal to the coefficient here, which is a is equal to 1. B is going to be equal to 6, and C will be equal to 5. All right, so once we do that, we're just going to plug them into here. So A is, so this will be 6b minus 4 times 1 times 5. And I try to make these numbers so you don't need a calculator. It is good to practice them without it. This could potentially be on an SAT without the calculator at hand. So this will just be 36. There's only one minus in this list, so this will be negative, and then 20. So this comes out to 16. So this tells us three things. It tells us we have two real answers. Okay, it's really important to understand that. Two real solutions. It also tells us that we have two x-intercepts, and very helpful for actually finding those x-intercepts. It actually tells us the problem is factorable. Remember, if this number, the discriminant, comes out to a perfect square, where 16 is a perfect square, then that number being a perfect square will tell me that it will factor when I ask for the x-intercept. So part one is done. Let's talk about putting this in vertex form. So to put this in vertex form, remember, we're going to complete the square. To do that, let's take a look at how to do that. So putting this in vertex form is done by doing the following. We are going to move the 5 over to the other side because we want to create a blank there so that we have room to complete the square. So now we have f of x minus 5 is equal to x squared plus 6 plus a blank. That blank is going to be filled in by completing the square. Remember, completing the square is simply to take half of b, so 6 divided by 2, and square that number. So that will be 3 squared, which is equal to 9. So put a 9 there. Don't forget to add it over here. You are balancing an equation. Then you will balance this side, so f of x plus 4. That is the h that you've seen many times. Well, almost. We'll have to move it around. This will then factor. So maybe at this point, if you wanted to factor it above here and say, okay, this is going to be x plus 3, remember that this number is always the same thing that you have right here. And so why don't we just go ahead and write x plus 3 squared here, because there are two of them. And to put it in our format for Algebra 2, we like to move the h back over. Again, if you're in pre-calc and you see that, you'll realize that sometimes pre-calc will actually leave it over there when you get to a certain section called conics. Depends on your teacher and what they prefer. But this year, we're going to move that h back over, and there we have our vertex form. So what is the vertex? Remember, the vertex is going to be the opposite of this number right here. So that would be negative 3, and then comma k, which is negative 4. And the new terminology for this chapter is the axis of symmetry. And the axis of symmetry is going to simply be x is equal to the first number. So x is equal to negative 3. Those are going to be important on the graph. So now we're going to find the x and y intercepts. And as you can see, this is just a great review of all the concepts so far from this chapter. So the x-intercepts, we know it's factorable. We're going to find the x-intercepts by setting it equal to 0. We know it factors, so this told us that. So we'll be able to do factorization pretty quickly. It is going to be 0 is equal to the original problem. This factors pretty readily because, again, we're doing an addition problem, and we have the choice of 1 times 5, or that's it, right? And 1 plus 5 is 6. So we're going to do, okay, what's going to be x plus? Remember, it's going to be positives, two positives. When this is an addition sign, these have to match, and they always are equivalent to the middle term. It's just going to be 1 and 5, because 1 and 5 multiply to 5, and they add the 6. And then I'm going to use a zero product property. X plus 1 is equal to 0. So x will equal -1. And then here we have x plus 5 is equal to 0. So x will equal -5. Please keep in mind that these are x-intercepts. So we're going to want to write them like this. -1, 0 and -5, 0. To do the y-intercept is similar, but actually always easier. And if you go back and look at the notes in standard form, it's always just c. So you could already know that it's 0, 5, but let's see why that happens. So if I do f of 0, and I plug the 0 into all of the x's, I'll have 0 squared plus 6 times 0, and then plus 5. These will cancel out, so I get that f of 0, which is the code in math for y-intercept, is equal to 5, but I'm going to want to write that as 0, inputted 0, outputted 5. And then the next thing you're going to do is just put all this together on paper. Let's see what it looks like. We'll start with the vertex. So if I put the vertex on a graph, that's going to go to my graph paper. We're going to go by ones. So -3, -4, which would be right here. Notice I went ahead and put the axis of symmetry there. My y-intercepts are -1, right? -1, 0, so here. And -5, 1, 2, 3, 4, 5, 0. Notice the perfect symmetry. My y-intercept is 0, 5, which is here. This tells me that I have two x-intercepts, which you can clearly see. So when I graph my graph, I can graph it pretty easily. And you can even, if you go back to your vertex form, practice your skills from Unit 2. Start at the vertex. There is no lead coefficient. So we would go 1, 1, as you can see there, 1, 1, as you can see there. 2 square is 4, -2 square is 4. All right, let's take a look at another example. Okay, so in this example, what we're going to do is we're going to take a look at what happens when some pieces are missing. It actually makes the problem easier if you know how to identify it. So this goes back to the solving. When we did solving, there's no c value. What that means is that c is actually equal to 0. But what it means for factoring is it means I'm going to factor using the GCF method. So let's see what the discriminant tells us about that, right? Discriminant should tell us that it factors. And let's see if that holds true, right? So A is 3, B is 9, and C is 0. So B would be 9 squared, and then -4 times 3 times 0. This entire thing will cancel, giving us 81. So that's why it will always factor if there's no C, because it will always just be a number squared. So that tells us again that we have two real answers. It also tells us that we have two x-intercepts, and it tells us that it is factorable. All right, so knowing that, let's move through the rest of it. How do we put it in vertex form? Well, vertex form is to take the problem and move over the C. Well, in this case, the C is already missing. So we can just go ahead and put a blank right here. Boom. We don't have anything. Don't need to move anything over. Don't forget that our next step will always be to factor out a lead coefficient. So I'm going to factor out 3. I did not do that on the previous example because the coefficient was 1, which made it unnecessary. And since this problem was a little easier with the blank there, I made that just a little bit more fraction-y. So we're going to take b over 2 and square it to complete the square, which will be 9/4. So we're going to put a 9/4 in the blank here. Please remember that when you add that over here, you're going to have 9/4, but then times this, because this would distribute. So we're going to multiply that times 3. And I know that that's kind of weird, but that's okay. I did that so that you would not have to add it to anything, just for practice with that. So that would be 27. Remember, there's a 1 on the bottom. So that would be 27/4. And then over here, we have the factorization, which the factorization is always just this number. So it's going to be x plus 3/2 squared, because the way we got this is x plus 3/2, and then another x plus 3/2. Just keep in mind that if you ever get stuck with completing the square, just remember that the answer is actually already on your paper right here. All right, so then we just move that over. So f of x is equal to 3x plus 3/2 squared. And then to move this over, we're going to subtract 27/4 over to the other side. Okay, and so that will give us our vertex. And yeah, it's a weird vertex, but of course you can always use a calculator and estimate that as a decimal. That's actually not a bad decimal to use, so just keep that in mind. All right, so the vertex would be negative 3/2, always opposite of h, and then comma 27/4. The axis of symmetry, which I'll just abbreviate axis of symmetry, is always the number that's the first part of the vertex. But you got to remember to put an x on there. So x equals negative 3/2. If you don't do that, you won't actually graph a line. So you want to make sure you have a line. All right, let's talk about the x-intercepts. This will be a really easy part as long as you remember that if their c is 0, then we are going to be doing GCF factoring, which is the first kind of factoring you learn, but kids forget all the time. So to find the x-intercept, we're going to set the problem equal to 0 and use GCF factoring. And when you do GCF factoring, one of your answers will always be 0, 0, which is really important for the next step as well. So we're going to take out the common 3 and the common x by dividing. So 3x squared divided by 3x is x, and 9x divided by 3x is 3. Then we will use the zero product property. So don't be afraid because this has less information than the other one. You're still just going to set this equal to 0 and divide by 3. And if you divide 0 by 3, you'll still get 0. Don't be afraid of zeros. They produce an answer of 0. And then x plus 3 will equal 0 here, giving you x is equal to negative 3. And those need to be written as x-intercepts. So 0, 0. And the other x-intercept is negative 3, 0. One thing that's really interesting about 0, 0 is watch what happens when I do the y-intercept. When I do the y-intercept and I find f of 0 and I plug 0 into the function, again, the function is 3x squared, so I'm going to have 3, 0 squared plus 9 times 0. Everything cancels out. Don't let that freak you out. These are all equal to 0. So f of 0 is 0, and what that tells you is that your y-intercept is also 0, 0. This is really important on every problem for the rest of the time that you take Algebra 2 or Calculus or Pre-Calculus or even Trigonometry. If one of your x-intercepts is 0, 0, your y-intercept is guaranteed to be 0, 0. They have to be the same thing. So let's take a look at how that works when we graph it. We're going to start by graphing the vertex, and I forgot to tell you what 27/4 was. So if you take 27/4 and that's confusing to you, 27 divided by 4 is 6.75. So we'll use that when we actually graph it. Okay, so we're going to go to negative 3 and 6.75. So sorry, negative 3/2 and 6.75. It's actually negative. Forgive me there. I noticed that I put an addition sign there, and you got to just be careful, right? So that's a minus, so that should be a minus. We fix that here. And it's important that you see little boo-boos like that because they're going to happen, right? And you need to make sure that you see someone go back and check. All right, so now we're going to graph it. I just saw that out of the corner of my eye, and I'm glad I caught it. So negative 3/2, that's this part right here. The axis of symmetry is x equals negative 3/2. The vertex is negative 3/2, comma, negative 6.75. So that's about, we'll just go right about there. It's an estimate, it doesn't have to be perfect. It's off the graph anyway. And then we're going to graph the x-intercepts. The x-intercepts are at 0, 0 and negative 3, 0. So we're going by ones, so 0, 0, and then 1, 2, 3. You can see that's perfectly in the middle. And the reason I don't have to graph the y-intercept is 0, 0 is actually on both the y and the x-axis. And so then you would graph it. And the reason that we're doing these variety of graphing is that one would be sort of hard to do from your transformational graphing, because how do you go 1, 1 from negative 6.75? It's important to understand these differences. And so that graphed it without having to worry about trying to move the transformational graph. It does have two x-intercepts, as we predicted, using the discriminant. All right, let's do one last problem. Okay, so this one right here has a fraction in the front, and I wanted to show you what that would mean. So the discriminant, okay, let's see what happens, is still going to be b squared minus 4ac. A is a fraction, b is negative 3, and c is positive 3, so we would have negative 3 squared minus 4 times a, which is a half. You can see why I picked a half. It's going to make the multiplication fairly simple. So here we would have negative 9 squared, which is 9. Remember, when you square something, it's always positive. This will be a subtraction because there's only one negative in this expression. And then we have 4 times a half, which is 2. 2 times 3 is 6. So we end up getting 3. Still going to have a real solution, right? We're going to have two real solutions here. And we're still going to have two x-intercepts. But this problem is not factorable, which is important to understand because that means we're going to have to solve it slightly differently, which we'll talk about when we get to that portion when we do x-intercepts. Okay, so let's talk about putting this in vertex form, okay, because we're going to have to factor that out. It actually works really nicely. And you might say to yourself, why is he giving us a fraction there? Because I just want to show you how that works. It actually is not as big of a problem as it seems like when we first get started here. We're going to start the problem as we normally would by getting rid of C and putting it over here so that we have a blank to hold that space. Okay, and so then what we're going to do is we're going to factor out the lead coefficient, which in this case is 1/2. So how do you factor out a half? Well, to factor out the 1/2, you're going to divide, that's what factoring out does, you're going to divide negative 3 by 1/2, which would actually reciprocate and multiply and make it 6. So that works out pretty well for us because that's actually going to complete the square pretty nicely because half of 6 is 3, right? So over here when we take half of negative 6, we're going to get negative 3. And then when we square it, we get 9. So as I said, it's not as bad as it looks. You just have to know that when you divide by a fraction, you reciprocate. Don't forget to add the 9 over here and then multiply times 1/2. All right, so we're going to have to clean up this side as well. So 3/2, if I want to add it to 9/2, let's see what that looks like. So negative 3 plus 9/2. I'm going to have to multiply this thing by 2 over 2 to make it 6/2. Negative 6/2 is negative 3. And I'm going to add that to 9/2, which comes out to positive 3/2. Don't forget there was originally an f of x here. And it's positive, so we'll say plus. And this side over here, we have 1/2. And the factorization is always, remember, it's just this, right? So don't ever freak out. So we're going to have x minus 3, x minus 3. And then over here, to do this part, we'll have 1/2 x minus 3 squared. And then we're going to move this piece back over to the other side. And this time I'll be a little more careful with making sure I keep the correct sign. It's important to see those little things that happen. Nobody does math perfectly. And the main thing we learn to do is to learn from our mistakes. All right. So let's take a look at what happens next. Okay, so that's the vertex form. So my vertex is going to be positive 3, opposite h, and then minus 3/2 as the k. And my axis of symmetry is going to be x equals 3. So now let's take a look at how to solve for the x-intercept. When things don't factor, they're actually easier to solve from this right here. Because remember, if you go back and look at the notes, to find an x-intercept, you can actually solve it by setting vertex or standard form equal to 0. In vertex form, you already have all the work done. It's already the completed square has already happened. So I'm actually going to do my x-intercept not using the standard form. I mean, I'd have to use the quadratic formula, but I've already done all the work. So why don't I use the completed square form, otherwise known as vertex form, to solve this problem? And don't worry, it's going to work out nicely with all those fractions. I set it up like that for you. So we're going to reverse the order of operations, starting with addition and subtraction. All right, so we're going to add that. So this will inverse out. And then we have 3/2, and I know you're afraid of those fractions, but they're going to cancel. Don't worry, as long as you do it in the correct order. So we did subtraction. That means we get to skip to multiplication. So don't ever distribute this. It doesn't have the same exponent. So we're going to multiply times 2 to cancel this. And then I'm going to multiply 2 over here. And as you can see, that wasn't so bad. So we end up getting 3, and that is equal to x minus 3 squared. And then we will take the square root. Don't forget your plus or minus here. All right. And so then we end up with plus or minus 3, square root of 3, and then you get x minus 3 here, and then you add 3 to both sides, and you'll get your x-intercepts, which to graph them, you're probably going to want to type them in a calculator because they are irrational. So your x-intercepts are 3 plus or minus the square root of 3 is equal to x, which written as x-intercepts, you can see I already typed them in here, but we'll write them out. The first one is 3 plus the square root of x, plus the square root of 3, 0, and then 3 minus the square root of 3, 0. And I typed them in so we could graph them in just a moment. The y-intercept is much easier, right? Because we're just going to plug 0 in, and always do that from the standard form if you have it, because you're going to get c. So here we would have 1/2 0 squared, and then we would have minus 3 times 0 plus 3. These cancel, and you honestly could have just written down from the beginning that f of 0 equaled 3, meaning we plugged in 0 and we got out 3. And you would get the same thing if you did it here, right? It would just be more work. If you plugged it in here, you'd have to add some fractions together and such, but so you always would do that from standard form. All right, let's get started graphing it. You can see that I already graphed the axis symmetry here at x equals 3, right? That's already done. And then we're going to graph the vertex. The vertex is going to show up at 3, negative 3/2, which is 1.5. So I'll put it right there. So 3, negative 1.5. My x-intercepts are these crazy irrational numbers. So they're approximately 1.2. So 1 and 0.2-ish. Oops, let me make that bigger. So 1 and maybe 0.2-ish right there. And then 4.73. So 1, 2, 3, 4, a little bit closer to 5. Notice how that line of symmetry helps you do that. The y-intercept is 0, 3, which is very helpful because if you needed to, you could also like kind of graph another one right there because it's symmetric. And then don't forget to actually draw the parabola. So one of the things I want to show you also that could easily happen is your teacher could change this equal sign, right? They could change this equal sign to a less than sign. And what that would mean is it would mean graph below the graph. So we would be shading all of the region that's below this. And sometimes it helps to draw a little person on here, right? And you can see below means feet. So you would actually shade all of this when somebody says less than the parabola. And notice that this one also, just to kind of correlate some things back from Unit 1, it doesn't have the equal sign. So that would mean you would actually have to go back and then make it a dotted line. And you might remember that from previous units or from even Algebra 1. So I just changed it subtly there at the end so you could see what would happen if we had a less than sign as opposed to an equal to sign. And why don't we go back and change another one? So let's take a look at the first one. It's a little bit easier to understand than that one. So let's say I made this one a greater than or equal to sign. What that's going to mean is it's going to be a solid line. We're not going to change that. But when we graph the greater to, again, it helps draw a little person. So it seems to be very helpful. Less than would be below the feet, but greater than would be where the person's head is, and you would just shade right here. And that would be what it would look like if it were greater than or equal to, because I didn't have to make it dotted. A lot of information there. You might have to rewatch parts of it. It's a great review for the entire chapter, so I would go ahead and take a nice look at that, maybe watch parts of it twice. Thank you, and I hope you enjoyed this video.